Thanks everybody for coming. Joint presentation between ABB and BASF. Basically going to talk about the risk and how we reduce the risk to do a greenfield facility in Elyria, Ohio using the ABB MEV approach. All right, to give you a little bit of background, I'm a senior project manager for ABB. I'm located in Wickliffe, Ohio.
I'm also a senior project engineer. I'm located in Greenville, Ohio. But as part of this presentation, I do another role in BASF, which is lead the electrical, kind of like a corporate, not really a corporate electrical group, but we have some overall responsibilities.
We figured we'd start out and give you a background what an MEV is for people that aren't familiar. It's a main electrical vendor, and it could also be main automation vendor. The approach is that it's an independent contractor that would take care of the engineering, the procurement, the construction on a project. And what sets it aside from a standard EPC approach is we take a proactive role in the project to transition from a vendor to a contractor. And as part of that, we have to basically form a partnership with the client. And our main goal is not to provide the least expensive option, but implement a solution that interfaces with all aspects of the project. So such in Elyria, it was a greenfield site, so we were interfacing with the general design of the facility, the civil, the structural, the electrical, mechanical requirements.
Kind of the significant difference in the project execution perspective, because in this approach, we look at the end. We don't look at the middle of it as much because it's an overall solution. We're not buying products, we're buying a solution, which means ABB needs to be, needed to be involved a lot more up front. And then they have to work closely with us in the overall plant designers because they were only doing a portion of this project. They weren't doing everything to make sure they got their part of it right and how it fit into the overall. But then that gave them the responsibility to coordinate and interface between the other parts of the project going on, the building construction, the overall civil. And then that provided, ABB provides a product solution utilizing ABB products. But in this case, we had to go to a third party because we did either ABB didn't have those products or we didn't like their products and we wanted to use somebody else's product. But that made them actually buy those parts, install them, and do everything. And then finally, at the end of the day, the final commissioning startup of a supplied solution. Because once again, we're looking for a solution. We don't want a bunch of parts and pieces and parts. That gives us the biggest single thing is a single point of contact for the entire scope of supply. Bob, his phone doesn't stop ringing some days because he's the single point of contact. Helps us reduce project risk. We have single point of contact. We have one person, one organization to talk with to get it right. Allows for some optimization. Already talked about the single contract. Ability to manage the interfaces with the other project participants. So you end up with the integration of everything. Hopefully that lowers the project cycle cost, integrates technology that ABB offers, and we end up with greater operability, lower training costs, and the ease of life cycle maintenance because we need to look at what it costs not to build the plant but to build it and operate it for 10 to 15 years because we don't want to be short-sighted in our cost analysis. In this particular project, ABB was actually awarded the main electrical vendor and the main automation vendor. So this slide shows a little bit of overlap between the two groups. The best part was Bob was the leader for both sides of the project, so he couldn't get away from things for quite a while. But at the end, the flawless execution that you would expect from a large company like ABB, and they were able to complete that. Obviously a drawing of the plant, not a real life picture. We'll get to some pictures a little bit later. Located in Elyria, Ohio. We used the 800XA system. We brought in a 69 kV transmission line. We had to develop a high voltage and medium voltage substation. Of course, then you get into the switch gear and their power distribution transformers. the main electrical vendor concept went through the motor control center. So, at some point you got to delimitate who's, where do you stop? It was to the MCCs, powering up the MCCs. We do have an emergency diesel generator on this project. That was kind of a late scope addition. And of course, everybody needs some UPSs to keep things going. And the important goal was to promote effective and timely communication. This was a fast track project. Most of the design was based out of our resources in Germany. And so it was quite interesting using United States talent, German talent, and basically BASF and ABB had United States talent and German talent working on this together. So it was a little bit of a learning experience along the way. And at the end of the day, we chose ABB to bring it all together for us.
The scope that we took on included the civil engineering, the structural engineering for the substation, the balance of electrical integration to pull that all together, the system integration, because we not only provided the micro-SCADA system to control the substation, we also provided the DCS to control the plant, and we tied those two systems together. But also tying in the UPSs with the generator, tying the medium voltage switchgear to the low voltage switchgear. We provided engineering coordination. We had a number of different engineering groups. We had substation engineering, we had civil engineering, structural engineering, low voltage systems. So we were responsible to bring all those different individual groups together to, again, provide the solution. We took care of all procurement of all the equipment and services, storage on site, installed all the equipment, the construction supervision and management, health and safety during the construction period, managed third-party vendors. Again, ABB was unable to complete the entire project scope on our own, so anything that was outside of our realm, we were responsible to hire those vendors, manage those vendors, and deal with their contracts. So to BASF, again, they had a single contract, and that was with ABB. The 800XA system was 500 hardwired I/O points, 100 I/O points through Profibus, and 900 I/O points through Ethernet IP. And using Ethernet IP gave us faster communication. All the process equipment was PLC controlled. So talking to the kiln, the grinders, the mills, that all came through Ethernet. So we didn't control that equipment, the PLC controlled the equipment, but we sent the starts, the stops, the change and set point. And that was all done through Ethernet. And then also the substation automation protection system. Again, we installed a micro-SCADA system, came out of our ABB group in Raleigh, and that took care of all the motorized switches, the relay protection, things like that you need to run the substation. And then going into the engineering scope, we completed all the load studies, the short circuit analysis, and the motor studies, the arc flash studies, harmonics. Again, bringing the whole project together, we provided all the arc flash labels for all the electrical panels in the entire plant. Again, the engineering goes down through the design of the substation, the transformer protection, the single line drawings, the interconnect drawings, the design of the DCS system with the 800M controllers, and the SAS 600 micro-SCADA system. So we prepared all that engineering, prepared all of the documentation, which was then used to provide the commissioning of the system. This is just a quick list of basically the equipment we supplied and what ABB factory, our business unit, provided that equipment. So you can see we've gone to South Boston, Bland, Lake Mary, Mount Pleasant, SLP in Mexico, Wickliffe, Raleigh, and then we get down into the third-party equipment that ABB doesn't have that Chuck mentioned, the ASCO auto transfer switch to tie in the emergency generator with the UPSs, The generator, we had to go to Cummins to provide the 350 kW generator. The UPS systems, we went to the Gutor to provide 3 different UPSs for us. And Natus is a small sort of system integrator that provided a small MCC for us. That was our power interface to the Noritake kiln that came from Japan. And then the main electrical room false floor, we'll get into that in a little bit. But again, as Chuck mentioned, this is a European designed facility. And in Europe, everything is bottom entry and everything sits on a false floor. Not per the American standard where we use cable tray and top entry. And that became a challenge. And then the structural steel. ABB doesn't fabricate steel, so we had a third-party contractor to design and fabricate it, delivered and erected all the steel for the substation.
Bottom line, it was a winning strategy. With BASF, you know, we provided all the products that they were approved. That's the reason you've seen some of the lists, like the Gutor UPSs, the Caterpillar. You know, we have a list of approved suppliers, and they had to follow it. Best price with the best execution plan. You know, common supply, using the ABB parts for all the electrical equipment within the ABB product line. As you know, walk out on the big floor, you see a lot of that stuff that we actually used in this project. They had done this a similar experience over with ABB in China, acting as an MEV, but it was the first time it was done in North America. As I stated earlier, ABB Germany and BASF Germany working together helped to maintain the effective communications. And that helped us develop a trust in the ABB electrical and MEV capabilities. Once again, the benefits: single point of contact, full integration, you know, of the microsata and the 800XA system, providing technical input from the electrical design, both from the German and the North American. There were some conflicts at times between the Germans said that they wanted to follow their standards, and we got our own standards, and this is the way business is normally done in North America. Sometimes we won, sometimes we lost, being on the North American side. Provided the overall project focus to help drive problems to completion. We'll talk more about that later. The overall project execution, you know, design, construct, startup, commissioning. They couldn't walk away with it until it was actually functioning. Technical interface to third party if needed, and we didn't have to involve, you know, all the different ABB entities. We involved ABB as a group that way.
So now we're going to go through the good, the bad, and the ugly, because as with all projects, everything didn't go flawlessly, and we did have our issues. So one is the main electrical floor, which I've already mentioned. It's a European design concept. The electrical cabinets sit on their own framework. So what I found was in Europe, there are European floor companies specifically make floors for electrical rooms, for the equipment to sit on their own frame, and the removable floor tiles come up to the frame. U.S. floor companies use the floor tiles as an integral member, structural member of the floor. So they want the weight to sit on the floor tile. This was unacceptable to BASF. So our solution was we built independent equipment frames out of Unistrut, anchored them to the concrete floor, and then built the floor system around the equipment frames. But once the equipment is set, it becomes a flawless system. You can't see the Unistrut frames, you just see the floor tile butting to the equipment door. This gives you total access underneath the floor, and has a nice finish to it. But also to implement this, we've ended up putting 3 levels of cable tray under a 39-inch floor. So basically, it was a challenge that we were able to overcome to meet the requirement of the project. The next one is the low voltage switchgear. Even though we completed an FAT of the switchgear at LPS, once we installed it and we're doing the final testing on site, we discovered that the main tie main had a hardwired interlock, which was unacceptable to the operation of the plant. I was able to get ABB low voltage field service in, and with their engineers, they corrected the wiring issue on the design documents, and the field service engineer rewired the switchgear at site, completed a thorough testing, and then we re-executed the SAT on site and corrected the problem, and we were able to move on. We were still within the original project schedule, so we created no delays for any other activities going on with the construction. The next was the emergency generator and auto transfer switch. We were midpoint of project development, and BASF was fast tracking the design of the facility, and came to the realization that they needed an emergency generator to provide backup to the kiln. Because of the power outage, the kiln has to go through a controlled cool period to protect the brick lining inside the kiln. So we provided the RFQ, went out to bid to 5 bidders with BASF, completed the bid evaluation, selected the vendor, issued the PO, completed the design. Again, the installation of the generator, the switch, and all of the testing that went along with that. And again, since this is not ABB equipment, we had the vendors provide all of the commissioning and installation and testing of that equipment and training of that equipment in the end to the BASF service people at site. The next was the high voltage CVTs. Is what we had an issue with. We had the substation done. We had safety inspections completed by BASF and First Energy. We had a nice group of people at site, and First Energy was going to energize for the first time. First Energy came in, they pulled in their switches, confirmed we had power on the system, went into the microscada system, looked at the meters to determine the incoming voltage, and found out that instead of 69 kVA, we were showing 29 kVA. So we realized we had a problem. Shut everything back off, had the commissioning company come back out. We ran some tests on the CVTs and found out that they had been wired incorrectly, and we shorted them to ground. So basically we fried all CVTs. Now, these are custom pieces of equipment that aren't manufactured until they're ordered. Very long lead times, and we had a completion date to meet so they could start testing of the kiln. Luckily, our Wichita Falls factory had inductive VTs on the assembly line that met our size requirement. Working with BASF, we got approval to make the change and had those on site in 10 days, installed in 5 days, retested and verified. And we were able to energize the substation within the schedule, again, causing no delays to the overall project timeline. These are just some pictures of again, to the end here, the site. So this is when we showed up on site, this is what we had. We had a gravel area that was being used for structural laydown. Here because of the soil conditions at site, we had to do a 6-foot cut in fill. And here we've already started the backfill, and we were pouring the foundations for the dead tank breaker, the structural steel framing, the transformer foundation and containment pit. And we had already, if you can see the small rods, we've already had the grounding system installed. But as usual, you dig a hole in the ground, and the next thing that happens is it rains. So that summer was the wettest summer on history for the Cleveland area. Again, but we were able to overcome that, deal with it, and maintain the schedule for the completion of the substation. So an overview, the piers in front are where the PDC building is going to sit. We've already started to lay the embedded cable trench. The structural steel is being erected. The fire blast wall for the 10 MVA transformer is in place. And We're about midway done with construction on the substation at this point. This is the substation's up to final grade now. The crushed granite is in place. The structural steel is done. And we're waiting for the building to show up. This is a 10 MVA transformer. This is delivery. This came out of our South Boston facility. You can see in the foreground the secondary bushings. We used a Pfister bushing as a BASF spec. That's a German product instead of a standard cable bushing. And also on this transformer we have a Rhinehouse tap changer that's in tank. It's the first one South Boston built. Again, it's a European design, but we were able to implement it on this project out of our South Boston facility. It's just a close-up picture of the secondaries showing the Pfister connections and then the cables going underground, running over to the PDC building and the medium voltage switchgear. Setting of the PDC building. Building was fabricated in Houston, and building showed up pre-installed with the medium voltage switchgear, the micro-SCADA system, all pre-wired, all tested at the building manufacturer site before we split the building. The building was shipped in 2 sections. Building design was a little bit of a challenge because the site only has 1 access point, and at the entrance of the access point is a railroad trestle, overhead or underpass that we have to go under, and it has a 14-foot clearance. So we had to keep the building under 14 feet and take into allowance the height of the truck and so forth. So it made the design of the building a little bit of a challenge to work around that issue.
Well, and the other thing is this building wasn't, they couldn't get it built to European specifications. European specifications would have said it would have had a false floor on it too, which would have added a couple more feet, and well, there's no way to get it underneath that railroad trestle. So they accepted the more traditional North American method of bottom cable entry in this case.
So that's the main reason the building is sitting on piers instead of on grade, is to provide the bottom access to the medium voltage switchgear. But here we're just about done with the substation. The fencing's going up, all the cables are installed. And at that time, the blue tarp was in place because we were dressing out the Pfister connections, and I think we had a drizzle that day, so we wanted to make sure that the cable stayed dry. It's just a ground view showing the PDC building, the cable bridge, running over to the main facility. Up on the 3rd floor roof is our secondary transformers that came out of Bland, Virginia. And these are the secondaries. FAR 2 transformers are 2 MVA, and the near transformer is 1 MVA. So the FAR 2, the facility needs 2 MVA, so those are 100% redundant transformers. And the near transformer, the 1 MVA, is only for the kiln power. That only supplies power to the kiln. So the 3 other bases are for the future kilns at the site. These are 5 lighting transformers that we provided. They were roof mounted because of the heat rejection. We didn't want to bring that into the main electrical room, which was air conditioned. So we put them up on the roof. Again, this is another example of a third-party product we went out. It's more of a commodity type transformer. So we went to a third party and provided those. It's the main electrical room. This is showing the levels of cable tray and the amount of cable tray that we have in the main electrical room. And also you could see the unistrut frames that the MCCs will sit on. And we pre-pulled the majority of the cable. And then once we had the cable in place, then the floor vendor came in and installed the false floor. This is our low voltage switchgear. It's double-ended with a main tie main. Up in the upper section are the high resistance ground units, going back to the 2 MVA transformers that are up on the roof. And you can see it was in middle of construction, 4 tiles are removed, that they're pulling cable and so forth. So this is the unit that we had to rewire on site because of the hardwire interlock. These are 2 of our MCC lineups that came out of SLP facility in Mexico. And this is the 480 volt Goodyear UPS. First cabinet's the battery cabinet. The middle four are the UPS, and the last cabinet is the power distribution cabinet going out to the feeds in the plant. And this is engineering control room. So this isn't the actual operator control room for the facility, but this is where we installed our clients for the engineers to sit during commissioning and startup, which is just off of the main electrical room and the I/O room, where we have all of our I/O and server cabinets. All three rooms had the false floor, and all cabling, Profibus, Ethernet, power is all under the floor. And that's about it.